Welcome everybody to the continuing learning group at Lancaster University. So we're a group that meets weekly during term time, and we encourage older people to take up studying either formally or informally and get to know the wonderful university that we've got at Lancaster. So I'm Janet, and I'm one of the organisers. David Pedder and Rita and Nigel Cole are also organisers and help us to put together a programme of lectures every term, manage some finances and deal with all the technical issues that we've got. So welcome everybody today. Very warm welcome again to Dr. Fiona Frank, who's our founder and mentor, and we've joined up with this term for these wonderful events all to do with Brazil and the rainforest. And our speaker, Dr. Camila Silva, who's here to talk to us today. But I'll just first of all hand you over to Fiona for a few words before Camila starts to speak.
Thanks a lot. So thank you so much to the Continuing Learning Group for hosting the 5 online talks. These are parts of a month of activities honouring Dom Phillips and Bruno Pereira and other people who have lost their lives defending the rainforest. And I've been saying that sentence most days now for a month, and it still takes my breath away. People who have lost their lives defending the rainforest, including Dom Phillips, who is the brother of Sian Phillips, who's a Lancaster musician. I've been playing music with her and singing. She leads my choir. I've been singing with her for 10 years. And she's lost her brother, who was an environmental journalist fighting for truth in reporting on the Amazon, and along with Bruno Pereira, who's an Indigenous expert. And they're not the only people that have lost their lives in this war, what Jonathan Watts from The Guardian calls a war on nature. So it's been a fantastic month. We're going to do a legacy website with recordings and notes and further reading about everything that we've done, including this talk, which is being recorded and will be available for the future. So hand back to Janet to do the introductions to Camila, and thank you very much for having us.
Thank you. So a warm welcome to Dr. Camila Silva. Virtual round of applause, and over to you, Camila.
Thanks, Janet. Thanks, Fiona. Should I start sharing my screen?
Yes.
Okay, so yeah, first of all, thanks to the audience to be here and come to see my talk. Also, thank you very much, Fiona, for inviting me. For me, it's a great honor to be part of this event, especially because we're here to remember and talk about the cause that Dom and Bruno fight for and believed, and this is a pleasure for me to take part on that. And I am a researcher at IPAM, which is an NGO that do research about the Amazon and also Cerrado, which is another biome in Brazil. I have recently finished my PhD at Lancaster University, and for most of the results that or data and some research that I will show you here, it's part of my PhD in collaboration with a group, Trees Lab in INPE, Brazil, which is the National Institute for Space Research. So today we're going to talk about how bad is the recent wildfire crisis that started around 2019 when all the world became aware of the fires in the Amazon. but also we still continue seeing these wildfires spreading all over the Amazon. So fires are present in all the Brazilian biomes. This map is showing the cumulative burned area since 1985. And Cerrado, this biome here in the center of Brazil, it's a biome that is dominated by a savanna vegetation. And this biome, it's expected, and it's actually holding the largest burnt area in Brazil. But what we shouldn't expect is that the Amazon has the second largest burnt area in Brazil, because the Amazon biome is dominated by rainforest, and which is a type of vegetation that is not adapted to fire and should not be burning so much. And as you know, the whole world became aware of the wildfires in the 2019 and 2020 crisis. This topic came up in the media a lot. We've seen pictures, videos, and while this was happening, our leader was blaming indigenous peoples, was blaming NGOs, and our former environmental minister was saying that Brazil actually was doing an excellent job. So everyone in Brazil was really disappointed, and especially the researchers that were dealing with this topic were very disappointed. And our leader also used this map to say that a lot of fires were happening in Africa, in California, and other regions, but everyone was just drawing their attentions to Brazil. And this is a typical thing that has been happening in Brazil. They use true data. This map is from NASA website. It's actually true data, but they use true data to tell lies, because what they don't tell people and what they don't clarify to people is that in many regions, fire is it's a normal thing, right? Like in many of these regions, for example, the African savannas, this type of vegetation has evolved with fire, and fire is part of that system. As in other ecosystems, such as temperate forests in California and other parts of the world. But in the Brazilian Amazon, fire is not natural, and it shouldn't not be happening. And what is also misleading from this image is that detection of fires in a very closed canopy forest is really difficult. That's why a map like that doesn't show very clear the extent of fires in the Amazon. And talking about that, it's very important to explain to people, to everyone, that the difference between fire adapted systems and non-fire adapted systems. So this is just some pictures from the vegetation from Cerrado, which is like a savanna. So this is a region right in the center of Cerrado, just after affected by fires. And then we can see on the other pictures how the vegetation recovered, because it's just a vegetation that has evolved with fire. So all the trees, all the shrubs, they have adaptations that allow them to recover fast after a fire event. But this is showing flooded forests right in the heart of the Amazon. This type of forest, flooded forest, has been studied by Bernardo Flores. He shared these pictures, and he has found that after fire events, these forests can lose about almost all the stems, all the trees are killed after a fire event if in this type of forest, which is very sensitive. And this is because in this kind of forest, the soil accumulates a lot of organic matter. So it's like a really deep organic matter and fuel that accumulates in this kind of forest. And once fires affect these areas, when of course when these forests are flooded according to the season. So when it's dry season and these forests are not flooded, and this fuel material is exposed and fires enter into this forest, it's a really serious damage. As we can see here on the third picture on the right side, the recovery is really slow, and the Bernardo's Flores studies has been showing that these forests might not recover on the next 100 years. And here, it's a typical rainforest, not flooded forest in the heart of the Amazon as well. This is the site. This is a site in Tapajós region in Central East Amazon. This area has been severely affected by fires during the 2015 and 2016 El Niños. I would just like to show you a video, a short video with that was taken with a drone. This is an intact forest canopy, as we can expect. So just few standing dead trees, and this is the same forest 3 years after the 2015 El Nino. So 3 years later, we still see that this forest is struggling to recover. We see plenty of dead standing trees and a massive destruction on the canopy of this forest. Here again, the scene of a healthy green canopy of an intact forest in Tapajós. We can see few dead standing trees, some gaps, all natural. This forest has not been affected by fires before. And then in the next, we see the same angle of view, the same forest that has been trying to recover from the fires for 3 years, but it still has a high number of dead trees, like very large gaps. And this is how burnt forests look like. So a lot of people say, and this is also some information that has been shared during the wildfire crisis, that Amazonian humid forests don't burn. And a lot of people struggle to understand why this happens. So for having fires in a humid forest, we need fuel. There is plenty of fuel. There is a lot of wood debris accumulated in the ground and leaf litter. And we need these two specific factors. We need low humidity, hot temperature, and ignition sources. When these three components are together, we can see fires spreading all over humid forests. It's also very important that we understand that not all the fires are the same in the Amazon. This is a bit complex scheme, but I will not go on in much detail here. I just want to show that the main types of fires are deforestation fire, which are fires that take place after a deforestation event. So basically, after the deforestation, all trees are cut down and then they are left in the site to dry. And after they're dry, people set this material, these dead trees, on fire, so they burn and disappear. We also have fires for pasture maintenance. We have agricultural fires and fires in open lands. All these fires, they can be these pasture and farm agriculture fires, they can be intentional, illegal or legal. And fires in open lands can be accidental, but they can also be malevolent, intent fires. And we have also forest fires that are usually uncontrolled fires that here we also call wildfires. So fires that come from one of those areas, deforestation or pasture or agriculture, and leak into forest, and then they become uncontrolled. This is a picture showing how a deforestation fire look like. So this is an intentional fire, as I said. After the trees are chopped down, they are left on the side, and then they are set on fire. And then fires from deforestation fire can escape into a green forest patch and then become uncontrolled. And this is a picture showing how a pasture or open land fire look like. This is usually also intentional, but that can also become uncontrolled. And this is what a forest fire look like. They usually, this kind of fire are low intensity, right? So the flames are not very high. They usually burn up to 30 or 50 centimeters from the ground, and they go burning for several days and sometimes for months, and they just spread in the understory, and they are very difficult to detect from the top. We just see the smoke. So to understand the recent crisis, the recent fire crisis, it's important that we look to the historical deforestation and fire trends. So forest fires, as I showed here, they are driven mainly by deforestation and droughts. So here in this graph, in the bars, we can see the active fire counts, so the amount of active fires that were detected in the Amazon, and the yellow line is the deforestation. So we can see that when we had very high deforestation during this time, we also had high fire counts. The symbols on the top represent the dry, the extremely dry years. So when also we had that extreme dry conditions, we had higher fire counts as well. And what happens here that is important to notice is that this deforestation was massively reduced since 2004, but recently the deforestation rates have been rising again. And this is the main cause for the peak that we've seen in 2019. This data is showing fire and deforestation until August. And in August, just after all this news came up in the media, the government implemented a moratoria that prohibited the use of fire for the next month. And we can see here in the graph on the right that deforestation in the red, which is the 2019 deforestation, was very high, especially in July, when we had the highest peak in fires as well. But just after the moratoria was implemented, that was reduced. And compared to the deforestation rates from 2016 to 2018, the 2019 was much higher, and that was what drove the forest fires. So deforestation-related fires is a consequence of weak governance. And if there is political will and political action, we can actually stop fires in the Amazon, and the 2019 is an example of that. This is showing a specific policy. As I showed you, the deforestation was decreasing really rapidly after 2004. And this is a consequence of a really efficient policy that we had in Brazil to control and prevent deforestation. And in the first phase, we saw a dramatic drop in the deforestation rates. But then as soon as this policy was interrupted in 2016, we saw deforestation increasing again. In 2009, Brazil made a commitment that it would reduce the deforestation rates by 80% in 2020. We just achieved a reduction of 44%, because without specific policies, we cannot meet our targets. And this is what exactly happened in 2020. This is just to show another data about the deforestation, which is the graph in the left, and the active fires, which is the graph in the right, in public forest lands, which are not, which are the areas where people were grabbing lands. So most of the deforestation, a lot of the deforestation has been increasing in these public lands. And this is a sign of land grabbing. This is a sign of land speculation. And as deforestation increases in this kind of land, we have also active fires increasing in the same type of lands. So this is also an evidence that deforestation, illegal deforestation in public land has been driving active fires in the Amazon. This is very recent study that has been released last week. This is showing that actually this year we had another record breaking. So in August this year, we actually surpassed the remarkable fire day in 2019, when was the day where land speculators and criminals agreed between themselves to set fire all together in these public lands in Brazil. And this year we've seen a higher number of active fires compared to 2019. These active fires are mostly concentrated in recent deforestation and in areas without any registry, which means public lands. Sorry. So this is again showing that if we have uncontrolled deforestation, if we don't have efficient policy to tackle land grabbing and land speculation, we're going to continue to see an increase of active fires being detected in the Amazon. So now moving more towards to the research I've done. This is basically, my research was focused on understanding how bad was the impacts of these wildfires to humid forests. I was looking to this problem with an ecological perspective. I was using long-term evaluation to see the ability of these forests to recover after the fires, and also to quantify the changes in the carbon stocks of these forests. So this is important. The importance of this kind of study is to understand the changes in the ecological process. So it's a study that has focused on long term. So here we can see a scheme representing what could be the trajectories of a forest in the Amazon, of a rainforest after a fire. In the long term, this forest may lose their ability to recover, and then they may look more like a forest with fewer trees, less carbon stock, more open forest, or they could also, in the long term, recover and go back to the pre-disturbance level state. But the thing we noticed is that most of the studies has focused on the short-term impacts, and we had a lack of studies looking to the long-term consequences of fires to these forests. We then set up over 60 permanent plots across the Amazon. This is just a map showing where the drought was affecting the forests in 2015. And also the fires were coincident in the same area. And this is showing where our plots are located. So these permanent plots, they are of course permanent, and we can revisit and we can remeasure the same sites over time to understand the changes that happened in each of these areas. And in it, we managed to measure over 9,000 trees, palms, and lianas during these campaigns. And I'll just show you how this happens. So to sample the vegetation, we have to measure the diameter of each single tree in a 0.25 hectare plot, so half of an hectare plot. And we had a really nice team of people, local people, helping us to measure all these trees in sites that were burned, but also in sites that were never burned, that were our control sites. And this is just a picture showing one of the sites that were actually burning at the same time that we were measuring the trees. When we enter these areas and when we see the fire, we actually don't see many trees dying from the fire, but this is a process that happens with time. And this is just another picture from our field campaign showing a path splitting the forest between a burned and unburned sites. So as the fires are understory and low intensity, if there is some interruption, the fire would just not cross to the other side. So this is just what some of the results that we found. So here in this graph, we can see the change in the stock over time. Each one of these symbols represent the different sites that we measured. And this is showing how big was the decrease in the carbon stock, in the biomass of this forest. There was some recovery in the medium term, around 10 to 12 years, but in the long term, the burned forests store about 25% less carbon than the unburned control forests. If we look, we also looked to the mortality rates and also to the growth rates over time. We can see that the balance between mortality and growth is really negative in the beginning, showing that there is more trees mortality than growth. But then with time, and then around 6 to 8 years after, we can see that these two rates, they are balanced. So this forest goes back to a neutral state where the forest in the long term is not losing more trees and not recovering, not growing more. So this is a neutral state, which means that this forest recovered up to a point, but not recovered completely the original carbon and the original amount of trees and species that it had before the fires. So we saw that that increase in growth is associated to small and medium-sized trees from all the sorts of species and wood density classes. But we also saw that the increase in mortality is associated to also small and medium-sized trees, but that is in the short term. And then later in the long term, there is an increase in mortality of large trees. So a forest that loses large and high wood density trees would take much longer than 30 years to recover. These trees, they are centenary trees. So we expect that these forests might take much more than 100 years to recover. And that's why we didn't detect any recovery in the time frame that we looked at. So degradation, what I'm talking about now, it's degradation. So I'm talking about fire, I'm talking about logging, I'm talking about edge effect, which is when the forest, when there is a deforestation, the edges of that forest are exposed to wind, to droughts. So all this is different from deforestation, which is forest clearance. The government, the media, the climate organizations and the climate conferences, they all focused on deforestation. But very recently, in 2020, there was this study showing that the degradation extent has now surpassed deforestation. And that's why we need also to call the attention of the authorities to degradation as well. This needs to be quantified and this needs to be tackled, not only deforestation, but degradation as well. These are two different problems. And because degradation is so important, we started trying to understand better which are the processes of fire degradation. We are now starting a new study to understand how much is the emissions from CO2 and other gases from fires in the Amazon. And we are focusing on fires, but also it's important that we understand the same processes from logging and from other processes as well. Here, from fire, we are trying to represent all these little processes in a model to quantify the emissions. So this scheme is, for example, showing how the emissions are in an unburned forest, which is carbon neutral. So all the CO2 that is uptaken is in balance with the CO2 that is released from dead wood debris and leaf litter, which we called necromass decomposition. But once this forest is set on fire, we have a massive release of CO2 and other gases to the atmosphere, and then we notice a peak, a really high peak in emissions from a combustion process. So in a humid forest, in a post canopy, the fires will be releasing emissions from the burn of necromass, not only not the live trees, but what is dead in the ground. And then in the short term, we see a lot of emissions from CO2 from this necromass decomposition, because in the short term we have an increase of trees mortality that accumulates wood in the ground that will be decomposed, and then that will release CO2 to the atmosphere. In the long term, with some recovery, we can see an increase in the uptake, but it's still this material that is dead and accumulated in the ground will continue releasing CO2 to the atmosphere. So a lot of the models, a lot of the studies has been concentrated in this phase, but not in this post-fire phase, which is still contributing to emissions of CO2 and of CO2 gases. In this phase, the phase of the combustion, we have emission of CO2 and non-CO2 gases, which are really bad for pollution and lung diseases and breathing problems. But in this phase, we have a higher contribution of CO2 that will contribute to global warming. This is the kind of data we need. This is provided by Map Biomas Fogo, which is a project that has been mapping burned area all over Brazil. And this is showing the age of fire. All these pixels are showing fires in the Brazilian Amazon. And this is showing the time since when the fire happened. So if you look to the blue areas, these are the fires that has happened more than 30 years ago, and is still contributing to emissions of CO2 to the atmosphere. So what we want to do is to extrapolate those processes that I showed here over maps like this, so we then be able to quantify emissions as function of time. That's what we need to do. We run a pilot study in the Brazilian Amazon, extrapolating those processes in burnt area maps, and we found that around more than 20,000 square kilometers of forests are burned within protected areas, which are these areas dashed, the shaded areas in the maps. All these forests, they are standing, they've been burned before, but they continue being mapped as healthy forests. But they actually working as a source of carbon. They are degraded, they are fire degraded, they are emitting carbon to the atmosphere, but into the Brazilian national systems, they are counted as a carbon sink. So this is the kind of information that we want to make available in reports and also publish in scientific journals to show that instead of having a system that only detects if there is forest or if there is deforestation, we need to understand if that forest had any sort of degradation, because it had fire degradation, for example. This is working as a carbon source and not a carbon sink. So under the new government, we have some positive perspectives. Brazil, as I showed, didn't meet by 2020 some commitments it made through the national climate policy. Now at COP26 last year, Brazil made new commitments to reduce greenhouse gases emissions by 50%. And the way the deforestation rates were increasing, we were going very far from meeting these commitments. But under the new government, we have perspectives that we are going back to the right route, especially because conversations are being happened between the new government and the very important environmental leaders that we had in the past and that are committed to putting Brazil in the right track again to meet the commitments that it had made. So here, just some take-home messages. It's important that we know that the recent fire crisis is not associated with extreme climate conditions, but is associated with a rise in deforestation that is a consequence of weak governments. We need specific policies to tackle fires in the Amazon. The 2019 crisis could be much worse if there was not a big pressure from international organizations and media. And then that was when the president decided to put in place the fire moratoria. Fires have a long-term impact on forests, and it can arrest these forests in a lower carbon state. And not only in a lower carbon state, but also these forests are poorer in terms of species composition and in terms of functions that it can provide. And it's urgent that we take into consideration fires and other types of degradation, such as logging, such as edge effect, not only deforestation. This is the brilliant team of people that has supported me over this time, and I want to say thanks to them as well. And yes, that's me today. Thank you so much. If you have questions, I will be happy to answer.